Today, as I write this, only one smooth trans focus, or STF, lens exists on the market for photographers to choose from. That's the Sony 135mm f2.8 t4.5 STF lens. Now, Fuji does make a lens with an apodization filter, their XF 56mm f1.2 APD lens. However, they do not, that I'm aware of, market it as an STF lens. Also, it was not engineered as an STF lens. It was based on a previous lens, and they added an apodizing filter in it to simulate an STF look in the images. This video will examine what makes the Sony STF lens special, and it is. How an STF lens works, what makes it an STF lens, why an STF lens is different than a standard lens, and why on earth does this thing have two sets of apertures? The Sony STF is a 135mm f2.8 lens. Now that said, because it has the apodization element in it, that cuts the amount of light wide open by a full stop. So it only transmits the same amount of light as f4.5 when it's wide open. That's why you'll see in the marketing and other materials f4.5. That's the T value, the transmission value, how much light is making it from the first piece of glass to the imaging plane. Now that one-stop light loss, it's not fixed. It's not a one-stop light loss for the entire aperture range. It's a sliding scale. And by the time you reach the end of the manual apertures range, which is T6.7, you're at f6.3. So the difference there is significantly different. I don't know exactly when, if at all, the light value and the aperture value catch up, but if they do, it's later on, something like an f16, f22 range. The Sony STF has an aperture range of f2.8 to f32, and it maintains pretty decent sharpness up until at least f16. On a full-frame camera, it has an angle of view of 18 degrees, and on an APS-C camera, it has an angle of view of 12 degrees. This lens is available on only one mount, the Alpha mount, which was started by Minolta but is now the Sony Alpha mount. There are Minolta copies of this lens available. Optically, they're identical to the Sony lens, but there's some construction differences that make the Minolta lenses a little bit heavier. The Sony STF is manual focus only. There's no autofocus option. Its dimensions are 8 centimeters by 10 centimeters. That's closed. It extends to a much longer length than 10 centimeters. This is a big lens, and it has the weight to back it up. The Sony version of this lens is 730 grams. The Minolta version, I believe, is somewhere in the 900 gram range. It's a heavy piece of glass. In terms of special features, this is an STF lens. That's special enough, but it's also manual focus only. It has two sets of apertures, one of which is controlled by the camera and one of which is controlled by the user. The user one overrides the camera's aperture if you're setting both of them. You can't actually set both of them. The way that it works is when you have the user aperture set to automatic, now the camera's aperture will take over. So that's if you wanted to shoot in program mode or shutter priority mode, you can do that. When you move the camera's manual aperture into anything other than automatic, the camera's aperture, the automatically controlled one, will not stop down at all. So if you want to use the camera controlled aperture, you have to set the manual aperture in automatic. Now that said, if you're not going to stop down beyond f6.3, which is t6.7, use the manual aperture. It's rounder and it gives a better quality to the out of focus area. In addition, the manual aperture, it's also stepless. So you can set it to anything you like, and if you have your camera in aperture priority mode, it'll take whatever exposure time is needed to match the aperture that you've set your manual aperture ring to. The STF lens exists to create smooth transitions between in focus and blurry areas without altering any object's original shapes in a manner that seems unnatural. That's really what makes the STF lens special. If you picture an in-focus point, let's picture an image. If you were to look at the way light moves when it hits the imaging plane, it's a bunch of tiny circles. And things that are in focus are the tiny circles. They're the tiniest, and that's why they appear to be in focus, because you have a bunch of tiny circles. It's like looking at a mosaic with infinitely tiny dots. But now if you instead make a mosaic with 6-inch across tiles, it's going to look blurry, especially if you're up close. So when you have an out of focus area, you're getting the same number of circles in that area as the in focus areas, but they overlap because they're much larger, which makes the out of focus area look blurry. That's what some people wrongly call bokeh. Bokeh is not the out of focus area. Bokeh is the shape of the circles of confusion within the out of focus area. I'll give you a second to absorb that. With a traditional lens, when you have an in-focus area, you have a small dot. With the STF lens, when you have an in-focus area, you have a small dot. With a traditional lens, when you have an out-of-focus area, you have a large dot, but it still has a well-defined perimeter. That's why bokeh shots, as they're called, have circles or ninja throwing stars or hexagons, whatever shape it is, for point light in the background. It's that it's on a different focus plane, so the circle of that spot is significantly larger. With the STF lens, because of the apodizing element, the out-of-focus spots are feathered. So instead of being a round circle that is a disk of out-of-focusness, it's a center area that's out of focus, and then a gradual tapering off into darkness of the out-of-focus area. Now when you overlap a whole bunch of these feathered areas, it becomes a really smooth out-of-focus area that has a nice characteristic to it, and a nice blending then from in focus to out of focus. There is no other lens ever made that was engineered to do this. There is no other lens ever made that does this as well as the Sony Alpha 135mm f2.8 t4.5 STF lens. Now, why does it do that? Now, I've said a few times it's because of the apodizing element. Now, here's a copy that I made of the lens's formula. I've shaded the apodizing element in gray. Now, if you imagine light going through all of this lens evenly, the light that goes through the apodizing element when the aperture is fully open is going to be going through the middle of the lens as well as the outside of that lens. The light going through the middle of the lens is going to be affected less by the gray tinting of the apodizing element. The light on the outside will be affected more. So what's happening is the lens is introducing light loss to every single point of light traveling through it. Now in the center, the in-focus area that's coming through, it's not really noticeable because the glass there is relatively thin. But on the outside, where the glass is relatively thick, there's a lot more light loss. That creates the feathering effect of the out-of-focus area that I mentioned before. Why is this different than just slapping an ND4 or ND16 filter on the front of your lens? Well, it's significantly different. A neutral density filter on the front of your lens is uniformly thick and uniformly graded. So if something, when light passes through it, it's going to have all of the light evenly removed. Because the apodizing element is concave, the amount of light darkening differs. So what would happen if you put a gradient filter with darker edges and a lighter middle on your camera, a vignetting filter? Well, that wouldn't have the same effect. That would be introducing vignetting into your image. It would not be introducing change to the way that light focuses as it moves through the lens. To get an STF effect with a lens, you need to have an STF lens. It is possible to simulate an STF look with multiple exposures, either for film as well as in digital. And I've written an article for Pentax forums about how to do that, and it's linked in the description below. To achieve the maximum STF effect with this lens, you'll want to use the manually controlled aperture. I found that f2.8 and f6.3, which are wide open and stopped all the way down with the manual aperture, provide the smoothest and most pleasing look to the out of focus areas. In these reviews, I also like to talk about some additional technical issues that come up, like coma, astigmatism, and others, if they're known. This lens has none of those. It did not exhibit light drop-off. I found no evidence whatsoever of any lens imperfections. There was no coma, no distortion that I could find. This was the most superbly engineered lens that I've ever held, from every aspect, from optics to image quality to construction. You'll have guessed by now that I love this lens, and if I had money, I would buy one for myself. It is, without question, the best portrait lens I've ever used. It beats my go-to portrait lens, the Pentax 77mm FA Limited, in terms of how it handles subjects. The FA is sharper, has better contrast transmission, but it's also unforgiving. The Sony STF is a lens that photographs people favorably. Let's clear up one internet myth right now. The STF lens is not a soft focus lens. This lens is in the top 10 sharpest lenses I've ever used. The STF effect is specifically engineered to create a pleasing out of focus area, but not to create soft focus. In addition to being hyper sharp, this lens has amazing build quality. It feels solid, has the weight to back that up, but for the feel, the focus is smooth and responsive. It's also very well balanced, and with a camera of suitable weight on the back, such as the Alpha 9 I used it with for 6 weeks, it feels balanced no matter where you're focusing. It doesn't feel like it's pulling the camera forward. That, to me, is an incredibly well-engineered lens. So what would this lens be ideal for? Portraits, of course. This has got a reputation as being the best portrait lens ever made, and maybe that's the case. I haven't used them all, I can't tell you. There are some other really good uses for this lens. Nature photography, especially of stationary objects. Flowers are a good example, would benefit from the STF effect. Macro photos, for instance, would be another thing. If you have some macro tubes to use with this lens, you could achieve some very nice macro images with the STF. Product photography is a great use of the STF lens. Some limited architectural work would also be good, but a telephoto lens isn't well suited to most architectural photography. This is not, however, a good lens for action. Despite the STF lens having a relatively fast maximum aperture for 135 of f2.8, the apodizing element causes a stop of light wide open. So even wide open, the STF sends much less light to your camera than equivalent 135 f2.8 lenses. That means you're losing a lot of light for sports photography, and you're going to find that you get blurry action shots. Now, the effect of the STF is largely eliminated as you stop down, but at the same time, you really don't want to be shooting action photography for sports at f22. As I write this, the Sony STF sells new for about $1,400 in the US. The older, generally identical, optically identical for certain, Minolta versions sell used for around $875. The STF lens takes some practice to use well. It takes some time to get to know and to learn. And if you aren't good at lens use in general, the STF is not going to work with you. That said, if you know how to use a manual focus lens, and if you know how to use a manual diaphragm, and if you're comfortable with having as much weight in your hands as the STF weighs, and if you're a photographer who can frame and shoot well and use the STF lens within its peak range, you'll be able to take shots with this lens that have a distinct look, near real-life quality, and a character that flatters your subjects. You will be able to obtain shots that other photographers without this lens cannot attain, because this lens is a special and unique offering in the world of camera optics. This lens is engineered superbly, and it is truly unfortunate that more lens makers don't provide true STF engineered options.